Okay, so welcome to this video on the chi-square test and the binomial test. Now, before we talk about the chi-square test, let us first have a look at what the chi-square distribution, how it looks like and how you can actually derive it. So for the chi-square distribution, consider that we are setting a particular parameter, and we will see that this will later be the degrees of freedom, that we set this to 10. Okay. Then if we are drawing, so in the first steps, we are drawing 10 observations, or we are randomly drawing 10 observations from a standard normal distribution. Okay. Remember that the standard normal distribution has a mean of 0 and variance or a standard deviation of 1. Now, what we would do next is that if we are summing up those 10 random draws, so assume that those draws are x1, x2, and so on, all the way to x10. Then if we are summing up all those draws and squaring them, or in the sense that we are first squaring them and then summing them up, then we get a variable called x, and this variable actually follows a chi-squared distribution with k degrees of freedom. Okay, so k here would be the degrees of freedom. Now, in the lecture notes, you actually have a histogram of how this would look like. Now, for the chi-square test, let us calculate using the example that is presented in the lecture notes about the general social survey data and the schooling level and the vote. Let us see of how we calculate the chi-square contribution. So here in this table or in this graph, you actually have the function cross table that is associated with the package gmodels. And we have here this cross table where we have the schooling, and we have whether the person participated in the 2020 election, or whether the respondent participated in the 2020 election. Now here I have two information in each cell. I have the number of respondents in each cell, and I have what is called the chi-square contribution. Now, for this particular example, let us actually focus on the cell of high school graduates and those who voted. And let us see of how we can actually calculate manually the 6.397. So note that the expected value in each cell, or the expected count in each cell, is equal to the total of the row times the total of the column divided by the total number of observations, or the total count. Here in this case, for the particular cell of people who voted and that have a high school degree, the total of the row is 1,453, and the total of the column, so this is this value here, and the column, the total is 2,474. And the total number of observations is the 3,155. Now, if you do that calculation, you get a value of 1,139.373. Now, this value is the expected count if we assume that there is no relationship between voting and the school level. Now, this calculation can be done for each cell, and then we can calculate the so-called chi-square test statistic. And note here, the test statistic is going from 1 to all the rows and columns. Here, in this case, we have a 5x2 table, so it would go from 1 to 10. And we have the observed value minus the expected value squared divided by the expected value. Now here I am just doing this for one cell, but you will have to do this for all the cells. So for one cell, that would, or for the cell that we are interested in, that would lead to the observed value, which is the 1054, minus the expected value, which is 1139.373 squared, and divided by the 1139.373. And this will give us, if you do the calculations, this gives you a value of 6.397. And note that this value is exactly what you have here. Okay. So this is how you calculate each individual contribution for each cell in this graph or in this table. Okay, so let us start doing some chi-square testing. And for this exercise, we are going to use the dataset General Social Survey. And specifically, we are going to look whether there is a relationship between voting, whether somebody has voted or not, at the schooling or the degree of schooling they have. So in the first step, we are going to subset the data to get only the data that we want. So we say df, and we're going to use the command subset for that, and we're going to subset GSS, and specifically we are going to subset the variable vote 20, and we are going to subset only the values 1 and 2. We are going to subset for degree, which refers to the degree of schooling. And then we are going to use the values from 0 to 4. And what those values mean, we are going to see in a little bit. And then we are also only interested in the year 2022. Now we are going to select the specific columns that we are actually interested in. And those columns would be the vote 20 and the degree. Okay. So now when you look at data, you have 3,155 observations with 1s and 0s and the degree here. So next what we're going to do is we are going to convert those 1s and 2 and those 1, 0 through 4 into something more meaningful. So specifically for the vote 20, we are going to say that if the person voted, that means if the vote 20 is equal to 1, then this remains a 1, otherwise it is a 0. And for the schooling, we need a little bit more work, in the sense that we are now going to use the values that are going from 0 to 4. We are attaching them to the specific levels of degrees. So 0 is associated with less than high school, 1 is equal to high school. Let's say that the 3 is equal to associate's degree or junior college. So that's just a junior college here. And that we then have the bachelor degree, and we have college. Okay. So here we have the schooling. And now note that we are creating another data frame that is converting, or that is basically summarizing the degree that is going from 0 to 4. And we are going to put that in a data frame such that the interpretation is a little bit easier. Yes. In the sense that you now have this degree where you have 0 less than high school, 1 is high school, 2 is junior college, 3 is bachelor, and 4 is college. Now the next step is not necessary, but it makes the table that we are going to look at a little bit more, a little bit easier to interpret. In the sense that usually what R is doing is that it is ordering something like the less than high school, or this vector values here of strings. It is ordering that by alphabetically. But here in this specific case, there's actually a meaning, or there's actually a rank behind those values. And hence we are going to say that the levels, we're going to use this function order. And we are going to say that the levels is basically ranked in this order here. Okay? So here I have a typo. Then I think that the value here should be, give me 1 second. So let's see what I have put in here. Okay, so DF schooling. Yes, I think I have not. So here this should be a degree and not DF. So now here it goes. And then we can merge the data frame DS with the data frame degree. And the value that we are going to merge by is degree. And now you see that we have here the 0 is associated with less than high school, and that you have, for example, 1 is associated with high school, and then the 0 or 1 indicates of whether that person has voted or not. Now let us use the function, or the package gmodels, because gmodels contains the function that is going to be called cross table. And for the cross table, we are going to use schooling, comma, whether they have voted. And here we are going to add a couple of additional parameters, because we do not need for the moment the proportion of the columns or the proportion of the rows that we usually get from the function cross table. We also don't need the total proportion here. And then what you see is this table that we have seen before. Okay? Where you have the 3,155 observations in total. And the cell that we have focused on before was the 6.397. So the 6.397 here is called the chi-square contribution. Now, if we want to conduct a chi-square test, then we can use the function chi-sq.test, and we can say the df degree, or the df degree. Let's do the df schooling, actually, comma df vote. And then you see here that the test result, or the hypothesis test result, that the p-value is very small. And what this indicates is that the hypothesis that there is no relationship between schooling and voting behavior, that hypothesis is not is rejected. So here there's evidence that there is a relationship between the level of schooling and the voting behavior, whether a person goes to vote or not, that there is a relationship here. Okay, so this is the hypothesis test, and specifically the chi-square hypothesis test. Now next, let us look at the binomial test. Okay, so here we have the binomial test. And now here, the story that we are going to look at is that we have the airlines degree, or the airlines data, and that specifically we are looking at the carrier of Delta Airlines. So this would be the L, and we are going to look at 2023. And suppose that they are saying that their arrival, there's less than a 5% chance of a flight arriving delayed into the Indianapolis airport. Okay? And now assume that we are looking for this data actually at December. So this would be the 12th. And then you see that we have 26 flights were delayed out of 370 arrival ones. So when you calculate 26 divided by 370, then you see that you have about 7% of flights delayed. Now, theoretically, we could do a t-test here on the proportion, but we do not have the original data actually. So we do not have the 370 flights with a 0 or 1. So here, what we can do instead is a so-called binomial test. So basically, what the binomial test does is it is looking of whether the values that we are obtaining, here the number of successes, which is, or the number of delays is 26 out of 370, and the airline claims that the probability of that is 0.05. And now here we are conducting a one-sided test, because the airline claims that it's less than 5%. So here we have to put, as the alternative, we have to put a greater. And if we are conducting this hypothesis test, then you see that the p-value is slightly above 5%. So what that means is that we are rejecting the, we are failing to reject the null hypothesis. So there is evidence that Delta Airlines here in this particular case is correct by stating that there is a less than 5% chance of arriving airplanes being delayed. Okay, so this is how you conduct a binomial test.